Hi guys, welcome to Amateur Chemistry. So as you might have guessed from the title of this video, today I am going to be making some diethyl ether from vodka. Diethyl ether is a very useful solvent for just generally doing chemistry, and I plan to use it to make a Grignard reaction in a future video. But how am I going to make it from vodka? Well, a molecule of diethyl ether is made out of two linked molecules of ethanol, and it just so happens that vodka is just some dilute ethanol. To make the ether, I first need to extract ethanol from vodka, purify it, and then chemically transform it into the diethyl ether. As always, on paper it sounds rather easy, but we'll see if it's so easy in practice. To start the extraction, I of course got myself a brand new, never before opened bottle of vodka, from which I had taken the label off, because I don't feel like promoting a random vodka company. I then opened it and poured it directly into a beaker, and it just felt weird, because I haven't seen someone do that in my whole life. Anyway, before starting to extract ethanol from my science vodka, I firstly wanted to take some measurements. I want to know the exact concentration of my vodka before proceeding, and to measure it, I can use a graduating cylinder, a scale, and this handy dandy chart with ethanol concentrations related to its density. After weighing 100 ml of the vodka, I calculated that it has a concentration of around 40%, which was also written on that label that I threw away. I also wanted to test the flammability of the vodka to later compare it to pure ethanol and diethyl ether. To do that, I got my trusty blowtorch and tried to ignite the vodka. It wasn't as easy as I expected, but after a few tries, I managed to light it on fire, and it produced a very dim blue flame, which was very hard to see even in the dark. The flammability of vodka isn't the best, since it is mostly water, which really likes to destroy most fires. Okay, so now that I know what I am working with, I need to separate the ethanol from water in the vodka, and to do that, I will use every chemist's most loved method, which is of course distillation. I actually already distilled some ethanol in a different video, but I didn't want to concentrate it, but rather to remove its impurities. I still have it, and today, after a few months of using it in my videos, I will turn it into its final form, which will be the diethyl ether. The distillation that I have to carry out to purify the vodka and my ethanol is not the simple one, which, as the name suggests, is pretty simple, but I instead have to carry out a fractional distillation. Fractional distillation involves the use of a fractionating column, which at least for me is a pain to work with. This is what it looks like, and it is just a long glass tube with some glass spikes inside, and my one also has these weird glass bubbles inside it. I don't know if they help to improve the distillation, but that is the only column that I could buy, so I will have to work with it. Anyway, I assembled my fractional distillation setup that looks like this. It is very tall and fragile, and I spent something like an hour trying to set it all up. I turned on the flow of water, and my puny little pump struggled to get the water up so high, and after it finally did, I wanted to start the distillation, but then I remembered that I haven't even loaded the boiling flask yet. I could pour the vodka into the flask from the top of the apparatus like a person with a normal fractionating column would do, but thanks to these goddamn bubbles, I had to leave the entire column up. But before doing this, I remembered that I wanted to add some boiling tubes to the flask to prevent the vodka from bumping, and to make them, I got a glass that I broke a few days ago and placed it into the mortar. The advantage of being a chemist is that if you break anything made out of glass, you can always just grind it down and say that you got some new boiling chips. And this is exactly what I am doing here. The broken glass is pretty hard to grind, but eventually I managed to grind everything down except a large piece of glass that just won't budge. To try to break it, I placed it on the floor and hit repeatedly with the pestle, but it won and ended up snapping my pestle in half. I was slightly annoyed at this, and because of that, I wanted to revenge my poor pestle, and to do that, I quickly made some thermite. I then proceeded to take my revenge in the form of turning this piece of glass into a volcano, and at first my thermite didn't want to ignite, but after a few seconds it burst into flames and was just beautiful. It ended up smashing the piece of glass into many small ones, so essentially it was just an improved pestle. I collected these small glass pieces and put them into the mortar along with the other ones, and after temporarily repairing my pestle with some tape, I ground everything down until the texture resembled that of gravel. I then lifted the fractionating column, got the boiling chips into the flask along with about 300 ml of vodka, and sealed the apparatus. I then turned on the heating and set the temperature to 85 degrees Celsius, which is a few degrees above the boiling point of ethanol. As the boiling flask heated, some of the ethanol vapor started to climb up the fractionating column, which was a good sign. After a few minutes of heating, I covered most of the apparatus with aluminum foil to make it more isolated. When I came back about 30 minutes later, I started to hear an extremely annoying sound from my apparatus, and when I got a closer look, it turned out that the glass bubbles started to have a mental breakdown. Anyway, I decided to increase the temperature to 100 degrees Celsius to make the distillation faster, and after a few minutes, I started collecting something in my receiving flask. The temperature of the vapor was around the boiling point of ethanol, so the distillate should consist of pretty pure ethanol. The rate of distillation was incredibly slow, and after a few hours, I turned off the heat and left my lab for the day. When I came back the next morning, I turned the heating on again and distilled the mixture for about 6 hours. Somewhere in the middle of those 6 hours, I turned the temperature up to around 110 degrees because my patience was slowly ending. After the 6 hours were up, the distillation seems to have stopped completely, and in the receiving flask, I can see a suspiciously small amount of the distillate. I transferred it into a smaller flask, and now it was time to weigh it to determine its concentration, but when I got my scale, it didn't turn on. I panicked a little because I don't have a different scale, and without one I can't do much, so I just ordered 2 new scales and waited for them to arrive. While waiting, I tried to see what happened to the broken one, and I figured out that a single piece of aluminum foil repairs it by enhancing the quality of the connection of the battery. It's quite sad that I didn't find that out earlier, because now I have a total of 3 scales and some very original batteries. Anyway, after this small inconvenience, I proceeded to weigh my distillate, which I hold to be pretty pure ethanol. The highest concentration that I could have gotten here is 95%, since ethanol forms an azeotrope with water, which prevents it from being concentrated further than 95% by distillation. 90% should also do the trick for me, but when I checked the weight of the distillate in the chart, I got a whopping 46% concentration. That's right, the hours that I spent on distilling this thing resulted in increasing its concentration by a mere 6%. I honestly don't know what I did wrong, but to improve for the next distillation, I changed a few things in my setup. Firstly, instead of a heating mantle, I used a hot water bath, which would limit the temperature to 100 degrees and provide more even heating. I also insulated the whole fractionating column with lots of aluminum foil for better insulation, and used a block of ice to cool the cooling water to condense the ethanol vapor more efficiently. I then filled the flask with some more vodka, started the heating, and hoped for the best. Again, the distillation was incredibly slow, taking almost a whole day, but this time I actually got a decent amount of the distillate and the vapor temperature didn't even cross 80 degrees Celsius, which was a good sign. When the distillate stopped coming over, I poured it into a small flask and proceeded to weigh it. I didn't have 100 milliliters, so I decided to weigh just 50 and multiply the result by 2. This time, the concentration was pretty high, hovering at around 90%, which was much better than the last time. That also meant that my distillation setup was finally properly working, and over the course of the next few days, I distilled the whole bottle of vodka along with my home distilled ethanol. The result of the distillation was some ethanol with a concentration of around 92%, which was even better than the first run. After combining all of the different distillates, I was left with about 200 milliliters of 91% ethanol, and before I go to the next step in making the diethyl ether, I wanted to test its flammability. It now should burn much better than the vodka, since it has only a tiny amount of water, and indeed it burns with a pretty bright blue-yellow flame and leaves almost no residue. And now, after all of the struggle to extract ethanol from vodka, I can finally start making the diethyl ether. But before I can go with the actual synthesis, I need to turn my 91% ethanol into some 100% ethanol, since the reaction of making diethyl ether only happens when there is little to no water. In theory, I could also use 95% ethanol, but I didn't want to stop there and just opted to bring it to the full 100. To do that, I need to use something fancier than just distillation, and it just so happens that a couple of days ago I brought some molecular sieves. They look like just some brown pebbles, but on molecular level they are covered with millions of tiny holes which are so small that only water molecules can get inside, and when they do, they get trapped in there, which makes molecular sieves a very powerful drying agent. However, before I can use them, I need to activate them, which means that I have to put them into an oven on maximum heat for a few hours to drive off any water and open up these tiny holes. I weighted out 90 grams of these sieves, which is a rough estimate of how much I will need to dry the ethanol, put them onto a baking tray, and loaded them into my trusty oven. I cranked the heat in the oven to the maximum, which is 250 degrees Celsius, and heated the sieves for around 4 hours. Ideally, I would have to leave them in there for 15 hours, but the idea of leaving a working oven being unsupervised for the whole night was not too ideal for me. After the 4 hours were up, I got the activated molecular sieves out of the oven, and they looked exactly the same as before, but now they were ready for use. To dry my ethanol, I just dumped all of the sieves into it and left it for the night. The next day, the ethanol looks much more cloudy, but that's probably because the dust from the sieves is falling off. To make the diethyl ether, I need to remove it, and just a simple gravity filtration is not enough, so I again have to distill it. This time, however, I fortunately won't be using a fractional distillation, because I just have to remove the dust from the sieves, so a simple one will be enough. After the distillation was complete, I was now left with some crystal clear ethanol stored over some more molecular sieves for that extra dryness, and I hoped that I managed to get it to 100% concentration. When I measured it, it isn't quite at 100% but really close, so it should be okay for the next step. And speaking of that, now it is finally time to make the diethyl ether. To do that, I have to react my ethanol with some sulfuric acid to dehydrate it and produce my desired diethyl ether. To prepare for the reaction, I firstly need to dropwise add 35 ml of 96% sulfuric acid into 40 ml of my ethanol under strong stirring and in an ice bath to premix them for the reaction. After about half an hour of dropwise adding the sulfuric acid so that the temperature doesn't exceed 30 degrees, I added some of the ultra pure sand that I made in the silicon dioxide video and assembled the rest of the apparatus. It looks pretty complicated, but essentially what it does is just produce and distill diethyl ether and resupply the reaction mixture with more ethanol. To get everything running, I placed an ice bath below the receiving flask and cooled the cooling water with some more ice. The water has to be very cold since the boiling point of diethyl ether is just 35 degrees Celsius, meaning that it is pretty hard to condense. I also attached a tube to the exhaust of the apparatus to vent any uncondensed vapors to be picked up by my fume hood, since diethyl ether is very flammable and I don't want my lab to turn into a barbecue party. After everything was set up, I turned on the heating mantle and the temperature of this reaction has to be maintained between 130 and 145 degrees Celsius, because if it is lower it doesn't work, and when it is higher, ethylene is created instead of diethyl ether. When the temperature got to around 135 degrees, I noticed some bubbles coming from the sand, which was a good sign because this is my diethyl ether. The sand provides a lot of surface area for it to boil and reduces the risk of bumping. After some time, I started to collect some product in the receiving flask, and now I had to start dripping in the rest of my ethanol. I have to adjust the dripping rate to resemble the distillation rate, because as the diethyl ether is distilling over, new ethanol has to be added. The whole distillation was really slow. It took about 5 hours, and in the end, I was left with about half a flask of my product, which was mostly diethyl ether. The next step is to purify it, because it still contains tons of impurities like sulfuric acid, ethanol and water, but after 5 hours of distillation, I didn't feel like doing anything, so I just wanted to put the ether aside for now, but it isn't as easy as just leaving it on my desk, because it will quickly evaporate. Even in a stoppered and greased flask, it still evaporated very quickly, and the only method to store it for the night was in a bottle reinforced with Teflon tape stored in a freezer. The next morning, all of the ether was fortunately still in the bottle, and now I had to purify it by washing it with a saturated sodium chloride and sodium bicarbonate solution. To prepare the solutions, I got myself 2 beakers and I filled one with 50 and the second with 100 milliliters of distilled water. I then dumped a lot of baking soda into the first beaker, and into the second one I put a ton of salt. The amount here is kind of random, and overall I just have to add a lot of everything to make the solution saturated. Now for the washing step, I got my separatory funnel onto the stand and loaded it with all of my impure diethyl ether. I then poured about half of the sodium bicarbonate solution into the separatory funnel, sealed it, and gave it a shake. It is important to vent the funnel a lot during the shaking, since diethyl ether evaporates insanely fast and might pop the stopper, which would be a disaster. The sodium bicarbonate wash serves to break down any remaining sulfuric acid, and the sodium chloride one is just to pull all of the remaining water out. After I was done washing the ether, I drained it into a flask, which I then filled with about 20 grams of anhydrous calcium chloride. The calcium chloride will serve as the final purifying agent, since it will remove all of the water and leftover ethanol, leaving behind pure diethyl ether. To make the calcium chloride work better, I put the flask into the freezer for about an hour. After the hour was up, I took it out, and the inside of the flask looked really dirty, but when I gave it a closer look, I noticed that the ether was actually pretty clear. I poured all of it into a graduating cylinder and weighted it, and it turned out that I got only 33 grams of the ether, which as always is an incredibly small yield, but since this project is about making some diethyl ether from vodka and not making an ether factory, I think that it is a pretty good yield to do some experiments on. The ether is still cloudy, and to clear it up, I could do a 4 distillations video, but I am just so sick of distilling stuff that I just said frick it and proceeded to vacuum filter the ether and call it a day. Anyway, now after all of the struggle with making the diethyl ether from vodka, I can make this video even longer and talk about its properties, and that's exactly what I'm going to do now. So, as I already said, diethyl ether is mainly used as a solvent in many reactions. It was also used as a general anesthetic, but it has been phased out due to its incredible flammability. And speaking of that, ether is really dangerous due to the fact that it evaporates incredibly quickly, and its vapors are 2.5 times denser than air, meaning that they tend to accumulate on the floor of not well ventilated rooms, and even the smallest source of ignition is enough to make diethyl ether's vapors quickly combust or explode. To test that in practice, I got myself an old baking tray, placed a small glass container on one side, and on the other I placed a small candle, which I then ignited. I then poured some of the ether into the glass container, and after a few seconds it set on fire. In a second test, I poured some ether onto the tray, left it to evaporate, and after it did, the tray just looks empty, but when I drop a burning match into it, it quickly catches fire. Some time ago, ether has been used as a recreational drug in many countries. It also smells kind of like ethanol, but has a more sweet aroma. Another danger of diethyl ether is that in presence of air and light, it slowly reacts with oxygen to create ether peroxides, which cause an explosion hazard when the ether is distilled. To counter this, a lot of compounds can be used to prevent the peroxide formation, and in my case, I used some potassium hydroxide. I also covered the ether bottle with aluminum foil and put it in the freezer for long-term storage. Anyway guys, to those few that made it that far into the longest video on this channel so far, thank you very much for watching, like and subscribe if you enjoyed the video, and big thanks go to my patrons, especially the $5+ ones, who are R2D2, Ryrie Leprogu, and Joseph Kudi. If you want to support my channel, you can also become a patron, and see you guys in the next video.